All right, people, here we are again, Investigation 5B. We're looking at part 2. Again, this time we're going to explore rolling friction. Now we're back to our standard car that you're used to. We've got the wheels attached, and this time we have two photo gates. So I've got gate A going on over here. I've got gate B over here. My timer is ready to go to give us information down below. Just a reminder on the timer, anytime the car goes through gate A and then gate B, we get three things. We get the A gate time, we get the B gate time, and we get the time in between. And today we're going to need all of that information. Here's the data table that you have. I've already filled in our masses because we've used those quite a bit. And again, here's the gate time at A, and our goal is to find out how fast the cart is going here. Here's our gate time at B, and our goal is to find out how fast the car is going here. But ultimately our goal is to find out, hey, how much friction force is slowing this thing down? So to do that, we're going to figure out, hey, how much does that speed change and how long does it take to change? So the third time, the AB gate time, is how long it takes to change. So again, all we're going to collect for this experiment is 3 sets of times for each different mass, and then it'll be your task to go ahead and work out the friction forces. So let's take some data. Here we go. So I've got my timer set up. I've got no ball bearings in the cart at this point. We're starting off with just an empty cart. This should say cart. I see it says sled, sorry. And let's go for it. Okay, I'm gonna go with that. My A photo gate time is 0.0072 seconds. My B time is 0.0078 seconds. Hey, that tells us something. Look at this, it takes more time to go through gate B, which probably lets you have a thought about the speed. Notice it's slowing down. That's interesting. That's what we're after. We're trying to recognize that it does slow down. Let's find out how long it took to make that slow down. It was 0.2965 seconds. So, hey, look at this. We got a car slowing down. From the speeds that you'll figure out, we can tell how much it slows down. From there, we can find the friction force. All right, off and running. Now, we're going to do the same thing again, but I'm going to add a single ball bearing. Again, this takes our mass up to 0.084. And here we go. Okay, same story. Original gate, A gate, 0.0087 seconds. B gate looks like 0.0096 seconds. And the time in between, a little more time now, 0.3654. Once again, notice the car clearly slows down as there's an increase in the gate time. And we're going to add another ball bearing, and again I'll space these so they're symmetrical just like that, and here we go. Okay, our A time, right smack at 1/100th of a second, 0.0100. Our B gate time, still getting bigger, 0.113. It seems like it's still slowing down. And the time in between, 0.4197 seconds. All right, and one more, folks. Here we go. We add the last ball bearing. And now, same idea, but even more mass on board. And away we go. Gate A time, 0.0111 seconds. Gate B time, 0.0127 seconds. And the time from gate A to gate B looks like 0.4712 seconds. Wow, that's just a bunch of numbers. But wait, we want to make sense of this. So that's your next job, but let's just take a quick look at this data one more time. What we're seeing is each of the photogate B times is larger than the photogate A times. That tells us the car was going less fast over here at gate B. It's slowing down. We're going to tell how much time it took to make that slow down. You're going to calculate the change in velocity, use it to find the acceleration, and from there we'll measure how much the friction force acts. Okay, that's your data set for Investigation 5B Part 2.